Good morning, good afternoon, good evening, wherever you are. Thank you for joining me today. Unfortunately, I am flying solo today. Alex is on holiday, but don't panic. He is going to be back next week. But we continue nevertheless. So let's get cracking. Of course, I always love this bit. It's my favourite bit. So say hello in the chat. Let me know where you're from, what time is it there, and we'll do a bit of a shout out as we go along. So welcome back to episode 3 of Discovering Aura Free. So we had a request last week by Fountainhook, which was to look at something chessy. So I couldn't get the World Cup data, so I needed to hunt around a bit more. Unfortunately, I ran out of a bit of time to look for that, but I have found a chess data set. So we're going to have a bit of fun with that. I'm pretty certain we're going to come back to more chess related stuff because I'm a bit of a chess fiend. I like chess. And there's lots of fun APIs out there that we can go and pull information. So we're definitely going to come back to that in a future episode. But we have a chessy thing to begin with. But first of all, let's quickly go through the plan. So I'm going to do a quick recap of what Neo4j Aura Free is. So as we progress in the series, we're going to drop this, but this is pretty new. So just to remind you all what it is and hopefully persuade you to go and get your free Neo4j Aura instance so that you can join along with us too. We're going to pick a data set. So this week we've picked some chess data. So I'm going to show you that data in a bit. And if you've got a data set you want us to explore in a future episode, let us know. So either sort of ping either me or Alex on Twitter. So I'm at @LLazal on Twitter. Alex is at Alexander Erdl on Twitter. Or shout out in the chat. So on the Twitch chat, we're keeping an eye on that, or the YouTube chat, or ping it in the PR and the repost. I'll give you address to the repost. This is where we keep all of the previous episode information. There are many ways. You'll figure out a way. And what we're going to do, so we've identified the data set, and the first thing we want to do before we can dive into what the data model might look like, we want to start thinking about what kinds of questions we might ask. So I've got a few questions I'm going to ask of this data set that I'm going to show you. If you've got any questions, pop them in the chat and we'll pick them up as we go along. You've all been very interactive in the past, so let's keep that enthusiasm going. But then, based on those questions, that's going to help us figure out what the data model is going to be. And then, using that data model, we are then going to go off and load data into our Neo4j Aura Free instance and ask those questions. So very quickly, what is Neo4j Aura? It is Neo4j's database as a service offering. So it's on the cloud. It's a managed service with elasticity, all of those good things. And it's managed graph infrastructure. And what Aura does for you, it will keep the database up to date. So as new versions come in, that's all handled by Aura. It will manage backups for you as well. And it provides continuous uptime and overseas monitoring as well. So all of that good stuff you would expect from a cloud service. So if you want to find out more, you've got the link there. So what's Neo4j Aura Free? It's a free version of Neo4j Aura. So you've got some limitations in there. So you're limited to 50,000 nodes and 175,000 relationships, but that is more than plenty to work with for a lot of scenarios. And as you've seen with our series, we creatively truncate the data if it's a very, very large data set to be able to fit it into those sets. You've still got access to Neo4j Bloom and browser. So we haven't used Neo4j Bloom yet, but we'll have a play in one of our future series where we can show you how to explore the data. But obviously we use browser a lot. It's free forever. And if you want to get to the landing page, again, you can use the same address and you'll have an option there to select the free instance. So we're going to get going now. And we're going to have a bit of fun here. This is going to require a bit of creative thinking, but it's good fun. And this week's data set, I had a quick search on GitHub. So what's really nice about the sessions we do here is we always go for a data set where we can pull it from a a URI somewhere so that we don't have to worry about downloading that data and uploading it somewhere and having to load it. So this makes it like really low friction with regards to being able to pull stuff. And I just did a quick search on GitHub looking for chess data that was in a CSV format. And I bumped into this rather interesting data set. So it's a Caruana Carlsen game. And what Zaid Kreshi's done is he's taken that and he's split that. So I'm going to show you in a second. So I've pulled it out from Zaid's GitHub repository. So big shout out to him. Thank you very much for having that. So I will ping the link as well to that repo over in the chat as well. If you're joining along, I'll probably give you the full one. So I've done the short one there for those of you who are catching up on the video so you can see it. So that's what we're going to look at. So let's go have a look at that data set. So this is the data set in question. Let me ping over the GitHub link in the chat. And what's interesting about this, and there's a bit of it, it rolls over to another page, but I think these are probably the columns that we're interested in. So this is all the same game. So you've got this ID here. I haven't dug into seeing the game. I'm going to guess here based on, did we get a date for this game? We'll have a look in a second. We'll look at the raw CSV. But we've got in here, we have got the, so we've got move number, fine, so it's the same game. So we've got the name, the name thing. So move number pair. So obviously in chess, we've got the move number pairs typically when we're recording a game of chess. Obviously, each person has moves. So these are almost like your half moves. So this move number is like a half move number. So obviously white moves first. So Caruana's played e4, then black moves. So Carlsen's replied with c5, obviously looking like a Sicilian here for those of you who follow opening theory of chess. And so we've got here the various bits of information. So we've got the move number. So that's like the half move. We've got the move number pair. So obviously we'll have two of those because white plays a move and then black plays a move. We have got the notation. So this is like the abbreviated algebraic notation. So that's a way of writing chess moves. And here we've got the full move. So the abbreviated notation gives you like the minimum amount of information required to go off and do that move, whereas the full algebraic notation tells you what was the original location of a piece before it moved and where it moved to. So that's why we got this E2, E4. From square, so obviously this is splitting out the full notation even further. So the from square E2, the to square E4. It says what piece moves. So this is going to be really cool for us because I've already got some ideas forming in my head, the kinds of fun questions I'm going to ask. So what piece moves? So here we know it was a pawn. So we've got a lower, is this capital? I think it's a capital, isn't it? You've got capital P to indicate either capital or lowercase. We'll figure it out when we pull the data in and have a look. So we've got here to indicate what moves. So we know here it's a pawn. Then obviously later on, so obviously you've got some sort of open Sicilian game going on here. So knight F3. So here we know a knight moved. We've got the color. So who was moving? And then we've got fen. So what fen? Fen is another kind of chess notation. And what fen tells us is that at any given time, this tells us what was the position of the board. So this is quite a neat way of being able to tell us what state the board looks like. So here, everything in lowercase indicates black, and with fen notation, you always work from the 8th rank down to the 1st rank. So this is obviously, these are all the black pieces, and obviously white's moved. So all of the black pieces will be in their home place. If there's an 8, that means there's no pieces in that rank. So obviously, you know, if you think about a chessboard setup, so yes, we expect 8, so nothing in there. We know that Caruana moved pawn to e4. So here we go. So what we say here, so here we split it up. So when it says 4, it basically means if you move across 4, those were all empty spaces. And then on the 5th space, so that there means there was a pawn, which we'd expect from pawn to e4. I should have put up a chessboard to talk this through, but keep with me. It's all good. It's all good. Then 3 empty spaces and then next rank and so on and so forth. So fen's a really nice way of doing that, which then pops another idea into my head that we can go off and query and have a bit of fun with. So there's a load more. So if I just quickly switch over to the raw data set, so you can see here, this is what we talked about. So we have got loads and loads of fields, because if I pop here, and it's going to look nicer when I query it into Neo4j, so maybe I will do that in a second so we can see what's going on. But you can see we've got a bunch of fields. So let me do that now so that it looks, it's a bit easier to see what's going on here, because it can be a bit hard in this. So I'm just going to jump over to here. I'm going to do load CSV with header from our link as row and return row limit 5. So we're not loading anything into the database. We're literally just pulling a copy of the CSV. So we're downloading a copy and then having a look at what's going on. So you can see here, there's been a lot of split out of the fen. So he's basically split out each of the rows. So this value here, what it looks like to me, what's going on, and quick check here sort of confirms my theory, is what he's doing here for each row is he's adding up the value of the pieces. So in chess, if you're not familiar, each of the pieces has a value, and convention states that rook's worth 5 points, and knight's worth 3, bishop's also worth 3, queen's worth 9, king is priceless. You want to keep that one, otherwise the game's a bit gone, and so forth. So if we very quickly tot up what's going on, so we've got 10, 16, 32 plus the queen. Oh, hello. Hang on. So 8, 11. Oh no, I can't add. That's what's gone wrong. So 11 times 2, 22 plus the queen, 31. So there's value. Pawns are worth a point each. So that's 8. So he's basically taken each fen row and put in the value of each of those. Okay, great. Is checkmate. So obviously got a flag there. Fen row, black value. Yeah, we know that. We're expecting all of fen row 1, black value. So he's doing it by... He's also totting up presumably from the black's perspective and white's perspective. So I assume there's some interesting application where this is probably going to be fed into some kind of chess engine. So maybe that's the purpose of the CSV here. And then you've got a lot of interesting things here. So is 50 moves? That's an interesting one. So I assume that's referring to the 50 move rule, which could be a question we might be able to ask. We'll have a look. 2 square. Okay, so that's, we looked at before, so that's where the score's going. Is 5-fold repetition. So that's interesting because it should be 3-fold repetition. So very, very quickly in chess, there's a number of ways you can get a draw. So you can get a draw by agreeing to draw with your opponent. So you offer a draw, they accept, you've got a draw. Another way you can get a draw is through stalemate. So if a move is made so that the opponent cannot make a legal move, that's stalemate. So that's another way you can draw. A third way you can draw is if you run out of time, but your opponent's got no material with which to create checkmate against you. That's another way you can draw. And another way you can draw is this idea of 50 moves. So if you make 50 moves, so not the half moves, the full moves. So if you both make 50 moves and a pawn and a capture never happens, that's another thing. You can claim a draw on that, which is why chess players roll their moves down so they can see if that happens. And another way you can draw is this idea of 3-fold repetition. So if the position repeats itself on the board 3 times, then you can claim a draw on that. And that might be one of the questions we might ask from our data. So you get the idea. So all these things. So most of this data we're going to ignore. And I think the bits that really are interesting for me here, if we pop back to this one here, is I think game idea we're not worried about because we all know that's from the same game. This would be very useful if we start bringing in other games, and maybe that's going to be an episode, I want for another episode in the future. But so we've got the ID. So the things we did, move ID, yeah, that's the move number. That's going to be interesting. So we can decide which one we want to do. So we can either go with this one and go, if it's odd, we know it's white. If it's even, we know it's black. Maybe we're going to just stick with that, and then we figure out how we're going to split out the black move. I don't think we need to worry about players because we know that Caruana is white and Carlsen is black. This is where it gets interesting now. So the other stuff now is, do we want to capture moves? Maybe. That might be interesting. I think we want to capture the pieces, and I'll talk about when my thinking is there. We probably don't need to worry about white and black. And the fen, I think, is going to be quite interesting. So that's a quick sort of whistle-stop tour of our data. So what questions do you want to ask of this data? So pop them into the chat, and I'm going to talk about some of the things that jumped in my head when I looked at this data set. So the things that I was looking at this and I thought would be interesting would be, I definitely want to capture the fen as a node. So I want to capture this information, and I want to store the fen as a node, because what this will allow us to do, it will allow us to, if I treat this as a merge, if I treat this as a unique thing, so I want to keep this distinct value here, and we can very easily see if a position has repeated itself. And I'd be quite keen to see as well, what was the move number when the position repeated itself? So that's something I want to ask. So I'm going to just jot down that question for myself. So I want to know, how many times did the position repeat? Or has a position repeated, and when did it repeat? Another question that jumps up that I think would be a bit of fun would be to have a look at what pieces were used most often, both for black and for white, and overall across the game. So I think that's a bit of silliness there. So how often was a piece used? And another bit of funness, I think, would be to see what's the most popular 2 square. I think that might be interesting as well. Maybe. I think that might be interesting to see what piece comes to that square. So yeah, okay, so let's start thinking about, so if you've got any suggested questions you want to ask of data, pop them in the chat. But what I'm going to do is I'm just going to start having a think about what this data model is going to look like. So let's bring up Arrows, our good friend. So if you're joining in with Arrows, here is a link if you want to have a play as well. So we said fen, so I'm going to go with the easy one, because this one's going to be interesting. So I don't think it's going to be obvious what this looks like. So I can put value, and oh goodness, this is going to be a real sort of mind boggler, isn't it? So I think we've got this concept of a move, haven't we? Let's put in move. And gonna have a number. Put move number. And let's put a position. Move, and move's going to be this one. And the reason why I'm using this one for the move is because we can basically chop this up. So if I want to ask the question about the popular destination square, we can. Okay, so we've got move, results in. Something like that. Position, oh goodness me. Has position, so a move has position fen. So that's, actually, let me just change that. Let's make it, I just call this fen. Okay, that makes a bit more sense. Position has moved fen. So what else did we want to ask our questions? We had, how often does a position repeat and when? So that's, we just look here, and then we'd count the number of relationships coming off there. How often was a piece used? Oh, yes. So where do we want to put that? Let's put a node in. Oh, would it look something like this, maybe? Let's just check what happens if we've got something like this. So I probably might get rid of this relationship here. I'm just going to talk through the rationale here. So what have we got? So we said we wanted to, let me just bring up my notes. So we said, how many times did a position repeat and when? So we could do that by, no, we can't do that, can we? Like this. Oh, no, we can. Because what we do is we just have a long relationship here. So we'd infer via this. So what we would do here is we'd count the number of moves, and then that will tell us how often the position repeats. So that's okay. How often was a piece used? We can do that via here. So we can count how often the piece was used, and then we can infer whether we can split out by players based on the move number. So we can do the odds and evens, and that can tell us. And you know what? I'm going to cheat slightly, and let's put an extra property on here. Let's put in color, so that can tell us what move color it was. Okay, cool. What is the most popular square? We can do that by here, and we can just take the move and truncate the back two squares. So I think that does everything. So I'm going to get rid of this. There'll be many ways we could have done this model, and there's probably a more efficient way of doing it. But I think for now, this answers all of our questions. So we've got all the information if we wanted to play out this game again. We can do that. And oh yeah, I wanted to ask. Oh, good question. Oh, good comment by Benufire. So the thing here is, as Benufire has just pointed out in the chat, so let me just pop that up, is the challenge here is if we wanted to know about a unique piece, so if we wanted to know, because obviously you get 2 knights each, you get 2 bishops each, you get 8 pawns each, that kind of thing. So whilst we know by type of piece and filter by color, we're not necessarily going to know by unique pieces. So I like how you think, Benufire. I really do. So let's think about, so what I'm going to do for now is I'm going to cheat slightly, and I'm going to skip that one for now. But I do like that question, and I'm going to have a little think in the background. So I'm quite keen to get some data in and do it. And then let's come back and see what could we do to iterate that model so that we can look at unique pieces. So we can do this. And what we could do to adjust this model would be for each starting position, presumably that's what we could do. So we could chain it by the position of where that piece moves. So let's have a think about for now how we do that. So I'm going to put that down as a question, because I think that's a great question, and I don't think that's something people tend to think about in chess analysis. So with bishops, it's slightly different because obviously they're in different coloured squares, so that's quite straightforward. But things like pawns or rooks or knights, I love that question. So I'm going to jot that down, and if we don't get to it today, I definitely want to revisit that, because I think that's a nice thinking there. So how to track individual pieces. I love that so much. And the other one we had was what's the most popular square? We can do that one. And the other one I wanted to do was count for 3-fold repetition. So how many, no, we've done that. How many times the position repeats and when. Okay, brilliant. So I'm going to do that. And I'm just going to quickly indulge myself on Benu's question there, which is, what might we do to track individual pieces? So what we would probably do is actually, no, I need to think about that. I can't think off the top of my head how to do it, but that is a great comment, and we'll come back to that. So here's a data model for now. So let's work with this and let's get some data in. So what we need, so we're going to do the fen, the move, the piece. So we're going to be using merge. Hey. So we'll merge on the piece type, we'll merge on the position, and these are going to be creates because we know those exist. So I'm going to have to remind, so actually no, I can cheat because we're going to have the number, move, and color, so that's all good. Right, so let's do this. So we have got our load, so let's just make this a bit smaller, and let's do the following. So we know there's less than 50,000 nodes, so we don't have to worry about doing any kind of thresholding or anything like that. So let's do a merge position p position fen, and that's going to be row dot, I think, was it just fen? Let's just double check. Oh yeah, row dot fen. There you go, that's handy. So it's right there. So doing a merge on that, we're going to do a merge on the piece, and that's going to be type, and that's going to be row dot, what did we say piece was? Piece. Oh, I like this. It's row dot piece, and then we're going to do a create a move, wasn't it? Move. I'll just do m colon move, and in there we have got the move, and that was fen dot. Sorry, that was row dot move. We had the color, which we've got in there. So I'm going to use my English spelling. Sorry to the US folk who will be tuning in later to watch this. So we've got color, and what else did we say we wanted in there? We wanted move number. Oh yeah, that's a handy one to have. So that's going to be number. And we had a few of these, didn't we? So I think what we can do is we can go with the move no pair. That was right, wasn't it? That's the one where we, move no pair. So, oh no, move no pair. That's what we want. So let's do that. Oh, wrong window. So move no. Oh, what's going on here? No. And as we know, all of these will come back in string. So I'm just going to cast that to an integer. So let's do to integer and just wrap that in. Okay, so we created those, and then we need to hook them all together. So let's do with p piece m, and then we're going to do. Oh, so we're gonna, so because we've got create for this one, what we can do here is we can create a relationship between here and here, because we know all of those are going to be unique, and that's the fastest thing to do. But here we're going to do a merge, because it could be a situation where a piece moves and we end up with the repeated position, but other pieces could move. So those two are going to merge, if that makes sense. And hopefully I can just do this in one go. If not, we'll just split out the query. So we're going to do create a move. And what did we say? Move involves a piece. And then we're going to do merge piece results in position. Right. Okay. So let's see what happens. Get some data in. Oh, that was quick. Right. Let's have a look at what this looks like then. So let's do match and return star. Hey. That's interesting. Of course, we would expect this. So the only thing we don't really have at the moment is we're not really connecting all the moves up, but that's okay. We can sort that out later. So that's, let me write a note to myself, is how do we, so I think when we start tracking the individual pieces, this is when things will start to connect up at the moment. But for now, we've probably got a bunch of little splinter graphs based around the different pieces, but that's okay. So just straight away, what's jumped up to me as a fun thing here is, do different pieces moving result in the same graph? Oh, we might jump into Bloom for this. This might be a bit fun. So let's quickly go and answer some of the questions first. And no, I'm going to jump into Bloom. I'm all over the place, but it's fun. It's fun. So let me just quickly log into Bloom, and I'll just talk through what I was going to look at. So Neo4j and my password. So the interesting thing that I just quickly, that jumps up here. So you notice how we're going to have these little islands. So if I bring up some more pieces, let me show you what I mean. So if I just minimize this window. So what we're going to find here, if I bring back pieces, so obviously we're going to have 6 pieces, 6 different types of pieces. And if I double click on these, then what you'll notice is that they're just going to be like little globes. So let me just minimize this a bit. So you're going to have these little globes, which makes sense because we're not connecting the rest of the game together. So what I'm curious about here is, does a situation arise where 2 different pieces moving result in the same fen position? So that's me popping all the mats. So you can see we've just got like little globes, like little islands. So let's go and see what happens when in Bloom. Does it ever happen that we have piece, position, piece? No, so it doesn't happen. So we can rewrite that query out in browser as well. So let's do match piece, results in a position, and I want to know about P2. Oh. Let's just check and see if different pieces result in the same position. So let's do pos, return pos. Oh, hello. So, okay, this is, let's return start. I think maybe, yeah, here we go. Now this is interesting. So what this is telling us here, so I think maybe that for Bloom, obviously it isn't necessarily going to write the most efficient cipher query here. So what we're saying here, which is very exciting, is that what's happened is that there's been 3 occurrences where either a rook moved or a king moved, and it resulted in the same position. Are these the same? Oh no, they're 3. So they're 3 different positions. But the interesting thing here is that's happened to. What's happened is that they've come in different places, and what's happened is that you've moved different pieces, but they result in the same position. So the other thing, if you remember, one of our questions that we had was, how many positions have repeated more than once? So straight off the bat here, we can say that at least 3 games resulted, but moving that. But obviously, the situation may happen where the same piece has moved. So we're going to have a look at that. And Tamaj has just asked, what does he need to do to get a 1700 rating? Lots of practice and dedication and determination and reading books. But playing lots of games and looking over your games. I don't think my efforts here in the graph are going to help with that, but it's all good. Right. Okay, cool. So that's that. So a little diversion there. So I'm going to copy this because I think that's a really fun query. But let's have a look at answering the first question, which is, how often did a position repeat and what was the position? So I'm going to recycle this query. And what I'm going to do here is I want to put in, so what I need to do is repeat the whole sequence. So remember, we said we've got a merge here. So something could have happened several times, but we don't know, because if it was identical between these two, then it's going to be there. So what we need to do is we need to include this entire path. So let's have a look at that. So let's do match. We've got a move, which used a piece. We'll keep it like this so we know what's going on, which resulted in a position. Okay. And then what we want to do is we want to count the number of times that moves resulted in the same position. So what we're going to do is we're going to return, actually, with position and with collect. Yeah, let's do that. So let's do collect M as moves, return position. Let's do, we said defend, wasn't it? Return position and size, isn't it? Size moves as size, or the by size, size descending. Right. Oh, hello. What's going on here? This is not what I was expecting. Are we seriously saying that this came back? Huh. This does not make sense, so let's see what's going on here. Let's just quickly do this. So this has caught me by surprise, I have to say. Return labels n count n, and this should hopefully tell us what we've got. So we have got 229 moves. That sounds like a lot of moves to me. So is this, have we got more than one game in here? And I've jumped the gun a bit slightly. Right, let me just quickly check this. Right, return distinct. What did we say it was called? We said it was called game ID. Oops, wrong one. No, it's the one game. So how many moves did it go down to? Oh no, they did actually have... They did actually have 115 moves. Well, that was a long game. My goodness. So they had a rook, they had a pawn, pawn, king, pawn, king. Okay, it was rook and no, it wasn't. Yeah, rook and pawn ending. Okay, so wrong one. Pop over here. Okay, so that makes sense. They did have that many moves. So let's just have a look at this. So let's look at the one that didn't repeat so often. So we've got this one, which apparently repeated 14 times. Something suspicious is going on here. What I'm going to quickly do... You know what I'm going to do? I'm just trying to think what's going on here. So what's happening here is we're using this as a branch. Now, what could be happening as well is that we could have different pieces coming into the same position, but that shouldn't be a problem because... So that would double what's going on. So we know we have those 3 instances where a rook and a king move results in the same position, but that's only 3 of the things where that's happening. So next question here is, do we have duplicate move nodes? Let's just quickly bring those out. Oh, wrong one. So let's do match move, return m dot no, m dot color, m dot move, order by m dot no. Now that all looks sensible to me. Yeah, okay. Wow. So this one's really interesting. So I'm now curious if there's something going on in here. So let's bring back some of these, because I'm now very much intrigued. So I'm just going to close all of these up until here. And we're going to go back to one of the other questions, because obviously we're spending a lot of time on this, because I'm quite keen to do the how often was a PC used question. So as moves limit 1, and then let's return start, and let's see what comes back. So I'll just grab a copy of this. Right, let's see. Turn start, and let's see what comes back. So we have got so 54, move 1. Oh, this is interesting. So it's saying that move 1. Okay, I see what's happening now. Because it's going via the pawn, so this is going via the number of moves. So we do in fact need to have this relationship between moves and position. So that's what's gone wrong, which is all good. We can just, so we may need to rethink what does this part of the model looks like, but that's fine. So we'll reload the data quickly and put that in. So that's like 2-second job. So I'm just going to do that now. I can just get rid of all that, and then just quickly pop in this, and then let's do a, oh no, I didn't mean to do that. Don't buy a cheap Bluetooth keyboard, is my top tip. So let's do create involves piece. Let's do a create move results in P, results in position. Right, okay. All fixed. So now very quickly, let's go back to this question. And I'm just going to recycle this. So what you're saying here, this is going to be results in. Oh, result. Oh dear, that's fine. It's all good. It's probably, I should have picked a different relationship type, but that's okay. So right, if we now do with position, collect M as moves, return that. Right, okay. Still not quite. Oh no, because I did the limit 1, didn't I? So no, there we go. Right, there we go. Problem solved. It's all been fixed. So you can see now these are all the positions where they've repeated twice. So there was no threefold repetition in the game. As you can see, there was no threefold repetition. The positions at most repeated twice. And these are all the positions that repeated twice. There we go. And then obviously the rest of those are going to be repeated once. So what we could have done is we could have put in a where clause to say where it's greater than 1. So let's just quickly do that. So I think I can do that here, can't I? Where size is greater than 1. Oh, put it in the wrong place. So it's just the guessing game of trying to remember where to put this in. So I probably have to do it up here. There we go. So this now pulls back all of the games, all of the positions where it repeated more than once. Brilliant. Okay. So next question was, how often was a piece used? So Benny's comment aside about being able to say track individual pieces. I love that question. So we'll have a look at that in the future, because I think that is stellar. But let's do this quickly. So we're going to do match move. And we know there's a piece involved here. Piece. And let's do return p.type. So it's going to tell us the piece type. And then we want to collect moves, don't we? So let's do with p collect m as moves. Then let's do return p.type and size moves as size order by size descending. And this is going to, so I'm surprised. Oh, no, I am surprised. I was expecting the pawns to be the most frequently moving pieces, but it turns out at the top, the rooks were moved the most number of times in this game, followed by the kings. So that's interesting. So kings tend to be very active. If you get into the end game of a chess game, they become really powerful pieces. So once the queens are off the board, you tend to see the kings being a lot more mobile and active. So the kings moved 46 times, and then it was the pawns. So that was a bit of a surprise. I was expecting the pawns to have moved the most, but that was not to be. Another question we had was, what is the most popular square? So similar theme as well. Here, I think we're just going to use the move node. So match move with, want to do right though, with right m dot move and 2 as destination. Return destination, count destination as C, order by C descending. So what's the most population destination square? C3. So C3 on the board. So for those of you who are not quite sure, so basically the move notation works where the letters, those go across the board. So it goes from A to H. And then the numbers go from 1 to 8 vertically. So C3, it's along the corridor 3, up the stairs 3. So that square was the most popular destination for pieces to go. And what's really fascinating here as well, if just for those of you who are a bit on the chess side, is interestingly, you would probably expect lots of activity to be towards the middle of the board. So anything between sort of C3, F3, F6, C6, so that kind of thing in there, and kind of seeing that. So here, 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 here. So you can see that all of these, those are the most typically the most commonly active squares. So this G7 is quite interesting. So I'm curious, if we look at the game, did we see like the king move back and forth there? So that was really cool and fun. And what we could have done to elaborate this further is we could have done square and piece. Is there like a popular square that piece went onto? So that's that one. So that's the that one. And we think we've got, yeah, so those are the 3 questions that I had. We've got 11 minutes left. So let's see if we can try and solve Benu's one, which is about how do we track individual pieces. So let's go back to our data model. So here what we'd change slightly is we'd have the individual piece. Great. Now, again, if you've got any thoughts on the stream, do chime in on the chat. I'm keeping an eye. And let's have a look at what we can do here. So I think this kind of, we're probably going to change it slightly where it's got type, and maybe we'd add a value like origin. So this would be the origin position. Actually, what I'm going to do is I want to duplicate this. So do I get an option to, no, I'll try and remind myself. So what I'm going to do here is I'm just going to shuffle this up a bit. Oh, that's completely pointless because it'll just rejig everything. So never mind. But let's, can I take all of this and can I duplicate? Oh, I can duplicate. Oh, look at that. That was handy. Right. So let's go in and have a look at this. So here we'd probably have a origin. This is where we put the origin square. So that's how we can track what piece it is, because it had an original position. And let's have a think about how do we follow it through. So what we could do, and this is massively hacky, and I'm sure there's better ways of doing this, and I think if I spend some time I can figure out. But what we could do is every time we bring in a new move, yes, Bennu, exactly. Yes, grabbing one's head. So a slightly hacky thing we might be able to do. If we come back to this, so remember we've got the nice thing about this move notation is it tells us what was the origin square for that piece and then where did it move to next. So what we might be able to do, and I'm going to have a fun time trying to think about the cipher query for this, but what we could do is every time a piece moves is we can use this to search for the origin square. Actually, I'm going to change that to current square, and then that's the piece we match and then update it. So could we do something like this? Actually, I'm going to change it. It's not going to be origin. Oh no, get rid of this. Don't want this. Oh, I love this. I love your question, Bennu, because I'm now totally psyched about solving this. So this is going to be location. And that's going to be the piece's current location on the board. So this is how we're going to be able to track everything. So what we can do here is we could do some kind of a rule where we can do something like if a piece at this location, so if a piece that doesn't match E2 doesn't exist, we create a new node. And if it does exist, then we update it, if that makes sense. So I'm going to have a think about how we write this query. But I love this question. I think this is amazing. So we're going to get rid of all the data again, and because I think we can still answer the questions about which was the most popular piece because we've got the piece type. So the thing we're adding now is the location. So let's think this through. Right. Okay. So, oh my goodness. So we're going to do merge. So we don't want to do a merge. We want to do some kind of. So let me write out the pseudocode for where I'm thinking, because it's this line here we want to change. So we want to do something along the lines of if. Oh no, we want to do it on the piece, don't we? Not the position's fine. We want to do something like this, don't we? Say if piece and if piece equals piece and location equals move left move 2, then you know, continue. But update location right move 2. With me so far, hopefully. Otherwise, we want to create or merge, or whatever we're going to do it. Otherwise, we want to create. Go on, then let's live life on the edge. Create, and then it's going to be piece equals piece. Piece equals piece, and right move. Oh, sweet. So, right. Benu's asked, are you planning to keep track of the actual square or recursively track the squares visited and eventually calculate the last path? Yeah, no, I'm not doing the last bit. That Benu's is for another episode. Although I do love that. I mean, do we want to do that? We could do that. We could have like a little path, couldn't we? Where we just see where it goes. Oh, I do like that. I'm definitely going to have to come back to that one because that's going to need a little bit more thoughtful model thinking. I'm just doing a cheaty hack that we just know where the pieces went. Although I guess we could reconstruct it even with the cheaty hack. I'll talk through how we can do that. So the cheaty hack, we can revisit it because we have these two nodes and we always know this node comes back. So we can always reconstitute and it's a bit messy, but we can always cycle back and forth through these ones to find out the journey of that piece. So we do have options to reconstitute that. Okay, right. So let's just check this logic here. So we're saying if the piece is row.piece and the location is row.left move. So if it already exists and now we're saying that it does that, then what we're going to do is we're going to update the location, but we don't need to create a new node. But if it doesn't exist, then we need to create a new node and move right. So I guess we could do a merge on this, couldn't we? And then we can do like a on create on set. So can we do that? So let's give this a go. So on piece and let's do a location is no, we can't do that. Oh no. Oh, actually, here we can. On create set piece dot location. No, we can't. Oh, got a question from Dingby Knight whilst I'm filling this. I just realised I can't do this, what I'm doing here, but that's all good. Quick question. I'm not forgetting your question, Benny. So quick question by Digby is, well, if and when the data science library is usable in Aura. So it's coming very soon. So the GDS library will not be available in Aura Free, but it will be available in Aura Professional. It's coming soon. Keep your eyes peeled. It's coming soon. Keep an eye out on all your various channels and things, and I'll give it a shout out on here as well when it's available. You do have GDS available in our sandbox as well, available now. So it's available in the blank sandbox, it's available in the StreetMap sandbox, it's available in the data science sandbox. So you can use it now in a cloud type environment, which is the sandbox. So the sandbox does last up to a maximum of 10 days which you need to do it, but it will be available in Aura Professional soon, so keep your eyes peeled for that and you will see it. So right, let's go back to this hacky query. So I don't think we can do this, so I think we need to do, I'm just trying to figure out how we do this. What we can do, we take advantage, actually no, we can't do that either. Oh my goodness. Can we do a merge on the start position? Yeah, we can. So what we could do is we could do a merge on this, and then on match, we set the new source. Oh yeah, I like this. Let's do this. Let's do this. I'm feeling good about this. So let's do merge row piece and location is row, going to be left. No, I think we want to do right, don't we? Oh no, that doesn't work either. because what we want it to do, because it's always going to be new. So I think we do need to have some kind of a if statement in here. I'm just trying to figure out how we can do this. I'm not sure I'm going to be able to solve in this minute, but I'm gonna keep plugging away at this. Oh my goodness. Right. So I think this is right. So what we're going to do is, so because when this happens, all we want to do is just update the location. If this doesn't exist, then we want to create the piece with a new location. Now, the problem is if we do it on, we're only going to do one pass over, aren't we? So you imagine here, it's going to create this. No, we can do this. We can do, no, this is fine. So I think we're right to begin with. So what we can do is merge piece, location, left, and then we just do it left, row dot move to, and then we're saying if it's on create, so if we're creating it for the first time, then we're going to change the location to right, row move to, and if it already exists on match, we do exactly the same query. I think that's going to work. I hope. Here goes nothing. All right, let's see if we've answered this. I'm sorry we're running a little bit late, but I feel we need to. Let's see if this works. So let's see how many pieces we've got. Let's do. So we should have 32 pieces if this worked. So let's do match and return labels and count star. Oh, okay, something went wrong here because we've got 144 pieces. We shouldn't have 144 pieces. So, did I forget to clean the database first? Oh, that should make a difference. I still shouldn't have 144 pieces. So something's gone horribly wrong here. So, okay, let's give it a few more minutes for those of you who can hang around. Otherwise, just catch it up on the recording. And just quickly before you'll go, so I will upload later on today. I will do a write-up of the session. So for those of you who have to disappear, there's a link you can catch up if you have to go now. And I'm keen to fix this. So let's just quickly check what's going through. Let's walk through the logic here. So we are saying merge piece, row piece, that's going to be the name, and its location. So that's going to be left. Yes. So if we're creating it, we're going to update the piece location to the next two. That's right. And if we're merging it, if we're matching it, we're updating it. So let's walk through this. So what we're saying is we would merge P and E2, and then if we're creating it, we then would update the move to the location to E4. And if there was like an E4, E5. I think the one thing where we're coming a cropper as well, so I think I may have to park this for now. I suspect the problem here is also happening because we're looking at this move color independent. So what happens if, for example, does E4 get captured at some point? So let's have a quick peek at, oh no, we don't want it in there. We want it over here. No, where's my little scroll bar? My scroll bar's disappeared. It's a disaster. So let's do E4, E5. There's E4, E5. Okay, there you go. So E4, E5. that happens at some point, so that's great. But I assume something may happen, like does e5, e6. Okay, that pawn's got e5, e7. Oh my goodness, that pawn travels far. But something may happen to that pawn at some point. So maybe it gets captured, and then that probably, yeah, here you go, look, f5, e7. So something's captured, f6, there you go. So f6, e7, so that was a bishop. So bishop's captured that pawn. And then that's probably registered as a new, piece, maybe? No, I need to think this through. So I won't forget about this. I think this is a great question. So we answered our main questions, which was how many times did a position repeat and when, how often was a piece used, and how popular is a square. So we did all of that, and then let's figure out how we can track the individual pieces. So I'll have a bit of a think about that, and I will write it up in the GitHub repository. So apart from that, thank you very much for joining me today. I hope you had fun. If you've got any data sets to suggest, you have a number of ways of doing it. So ping me on Twitter. So my handle is @LLazal. So I'll just log that into the chat. You also raise a PR on the repo. So you've got the address to the repo there, raise that as well. And we've got a music data set, which has been suggested. So we will cover that one next episode. So if you've got any other ideas, chuck them in. We'll look at those. And otherwise, thank you for joining me. Alex will be back with me next week. I hope you have a fabulous rest of your day, and see you later.